Now let's discuss relational data. A database is a place to store data for data storage. And we can also use something like SQL or the structured query language to query our data, right? So it has data storage and query capabilities. This includes things like selecting records created between given dates or updating a record that matches a certain criteria. So whether it's to store financial transaction information or something like customer information, databases are the backbone of most of the world at this point. Everything is driven by data now, as we know. Every website, every piece of software. So this being the case, the database software you choose itself is incredibly valuable. One type of database we can use, and that we're going to touch on here, is a relational database. A relational database provides a model for storing the data, or a schema, and the query capabilities that enables us to retrieve that data quickly. A relational database splits data up into tables. So each row represents some piece of data. Rows in one table will often contain a reference to something in another table that shows that they're related. The vast majority of databases used these days are relational. One common example would be a simple employee department manager database. You might have one table that contains a list of departments and gives each of them an ID. Employees would have a separate table with an employee ID, their name, and the ID of the department. So to keep track of who runs departments, you may have a third table for managers that just has an employee ID and department. So that is all relational. All these entries relate to each other. And if you get into the real nitty-gritty of how relational databases work, you'll see that they're mathematically based on relational algebra. So relational databases. When we design a relational database, we need to create a data model. Columns marked PK are your primary key for the table. Your primary key uniquely identifies the data within the table, and you can have only one primary key per table. You can also have a foreign key. These columns marked FK are foreign key columns. They reference or they're a link to the primary key of another table, and they're used to maintain that relationship that we talk about. Foreign keys in a table can be a primary key in another table. Some relational database characteristics. A relational database is normalized, so it depends on normalization. It has a schema, right, or a set, rigid way of storing that data. All data is tabular, so it's all based on tables. Okay, an instance of an entity in a row in a table, and each property is defined as a column. So it's a schema. You'll keep hearing this again and again. Columns stay the same for all rows in a table, so they're consistent. Table rows have no limit, so we can store as many rows as we need in a table. Relational databases can become very big. Primary key identifies each row, and no two rows can share the same primary key. And foreign key references rows in related tables. So we use the foreign keys to reference a row in another table to create these joins and to be able to show our data in one big picture as opposed to just table by table. SQL is supported by most relational databases. So when we want to pull data out of our relational database, we have to use the structured query language. SQL is supported again by most relational databases. You can create tables using SQL. You can insert rows into tables. You can update rows into tables, all using just SQL commands. We can delete rows. We can delete tables. And most importantly, we can query the data out. So rather than retrieve every row, we can use queries and filters, right, to pull out what we want. So we can use a where clause. Select all from customers where country equals Canada. so we can get all of our Canadian customers. We can combine data from multiple tables in a query using a join operation. A join operation spans the relationships between the tables and enables us to retrieve the data from more than one table at a time. So what are some relational database use cases? First of all, online transaction processing. Online transaction processing is database software designed to support transaction-related applications on the internet. OLTP database systems are commonly used for order entry, financial transactions, customer-related management, and retail sales. We'll discuss this in further courses down the road. Internet of Things or IoT solutions. They require speed because we maybe are collecting data from remote parts of the world. We can have IoT devices at traffic lights. We can have IoT devices in oil tank sensors, right? So we need to get that data quick and reliably, and we need to process it from all these edge devices all over the world. Relational databases can offer that small footprint that we need for an IoT workload with the ability to be able to be embedded into these gateway devices, these small physical gateway devices, and we can pull that data back and run our queries as needed. So relational databases work great with that regards. And data warehouses. So in a data warehousing environment, relational databases can be optimized for OLAP or online analytical processing. So where we take data, historical data from multiple different sources, and we analyze it for business intelligence and strategic advantages. So a lot of the times they use a dimensional approach, and we facilitate queries on massive amounts of data. And then it has that innate ability to summarize that data in multiple ways and present it to stakeholders in the organization. So it's a really great resource for data warehousing and business intelligence. Now let's discuss data store models. Modern business systems today take in a lot of heterogeneous data. This data is any data with high variability of data types and formats, so it doesn't adhere to one specific schema. So with that being said, sometimes it's better to store different types of data in different data stores. Each has its own focus towards a specific workload or usage pattern. This is what we call polyglot persistence, right? So it's used to describe solutions that use a mix of different data store techniques. Some of these can be SQL or no SQL databases. Depending on the requirements is the key. SQL databases use a schema. They're to a specific format, and data has to be in that specific schema. NoSQL databases are much less schema related. You can store many different types of data in a lot of different formats. So that brings us to what we call the multi-model support. We need to have something, and a lot of times something like a relational database may also support key value or graph storage. So relational database is SQL, but in some cases they may support no SQL or key value databases or even something like graph storage. We need to know what requirements when we actually set up our data store and what we're going to use for our application. So what's the feature set going to be? Is it going to be SQL, NoSQL, graph storage? We got to obviously bring in cost, right? Cost is important, and ease of management, right? We don't want to get something that's really cheap on the front end cost-wise, but just a nightmare to manage and really expensive to manage. So it all has to kind of balance each other out. Relational database management systems, RDMS. Right, these relational databases organize data as a series of two-dimensional tables with rows and columns. Most database management systems provide a dialect of SQL for pulling back your data, creating tables, inserting data. So an RDMS typically implements a transactional consistent mechanism that conforms to the ACID model for updating information. Atomic, meaning it's the lowest level of data that we can store. It's consistent. Everyone should pull back the same results. No one should be getting different results. It can isolate and secure your data as needed, and it's durable. It's backup. You can restore it. And a lot of times you can run these relational database systems across multiple regions, right? And we can make it high availability and highly durable. Key value stores. Sometimes we refer to those as a NoSQL database, right? These use what they call a unique key. So a key value store associates each data value with this unique key. Most key value stores only support, say, simple query, simple insert, and simple delete operations. It is used to retrieve and store values by this key. So that's what makes the unique key so important, is that we'll retrieve and store our value by that one unique key. It's highly optimized for performing simple lookups, but less suitable if you need to query data across different key value stores. And key value stores are not optimized for querying by value. So we don't really bring in select all where country equals a value of Canada, for instance. Right? So it's not really optimized for that, but it's good for simple lookups. A document database. A document database is a type of non-relational database. It's designed to store and query data as JSON-like documents. These can be simple values. These can be complex elements. Document databases make it easier for developers to store and query data in a database by using the same document model format that they use in their application code. Typically, a document contains the data for a single entity, such as a customer or an order, but it can also contain information that would be spread across several relational database tables if you're using a relational database management system. Documents don't need to have the same structure, which makes it good. Again, this is what we call schemaless. And applications can store different data in documents as business requirements changes. So an Azure Cosmos DB SQL API can perform a document database for you. A graph database. Put simply, a graph database is a database designed to treat the relationships between data just as important as the data itself. It's made up of nodes and edges. So edges specify relationships between nodes. Nodes and edges can have properties that provide information about that node or edge, similar, say, to columns in a table. Edges can also have a direction indicating the nature of the relationship. So if you want to say find all employees who report directly to Sean, or who works in the same department as Sadie, then you can go ahead and pull that back. For large graphs with a lot of entities and relationships, you can really perform some complex analysis really quickly. The Azure Cosmos DB Gremlin API is an example of a graph database that you can use. Data analytics. Major buzz around data analytics these days. Data analytics allows us to really run data analysis on massively huge scale data. Okay, so the data could be distributed across multiple servers all over the world. So we need to ingest them. We need to store all this data, and we need to be able to analyze it. So you can have some like CSV files or ORC. These files are widely used in data analytics. Historical data is typically stored in data storage like blob storage, but you can also use the Azure Data Lake Storage Generation 2. So Azure offers some data analytics services such as Synapse Analytics, Data Lake, Data Explorer, Analysis Services, and Azure Databricks. The column family database. A column family database organizes data into rows and columns. So really, in its really stripped down, simplest form, a column family database can appear to be a relational database, but mostly just conceptually. The real power of these column family databases lies in the kind of unorthodox, denormalized approach to structuring the sparse data. So think of the family database as holding tabular data, right? Just like a relational database with rows and columns, but the columns are divided into column families. Each column family holds a set of columns that are logically related together. Other data that is accessed separately can be stored in separate column families. So we may have a custom column family for customers. We may have a column family for orders. Columns can be added dynamically. Rows can be sparse. We store data in the key order rather than by computing a hash. Indexes can be created over specific columns, right? So we can fine-tune it even better that way as well. Search engine database. A search engine database allows applications to search for information held in external data stores. A search engine database allows you to index massive amounts of volumes, so we can access in near real time. And it provides near real-time access to these indexes. So this is something you may want to use if you need to get your application to search for information in data stores outside of your own environment or your own application. A time series database. These are used as a set of values organized by time. So time series databases usually hold a large number of records, and the size can grow rapidly because these time series databases, they collect a lot amount of data in real time. This may be IoT devices, whatever the case may be. Although the records are written to a time series databases are small, once we actually start to pull in and ingest massive amounts of data, these can grow very rapidly. Azure offers a time series insights that can give you a time series database that you can use for some of your workloads or any of your applications, such as IoT devices or anything you need to store in a time series. Object storage. So object storage is raw, unformatted storage that we just want to put objects into, right? So it's optimized for storing large amounts of, say, audio or video streams, image files. If your application needs to upload images, object storage is for you. It can be for files and documents. Maybe you need a file store where users can go and download some files. It's good for images and large data objects, right? So we can use the Azure Blob Storage or the Azure Data Lake Storage Gen 2 to create some object storage for us and our application. Another good thing we can use for object storage is to store our virtual machine disk images. So if we're spinning up new virtual machines in the cloud, we want to store these disk images somewhere. Again, they're large files. Let's put it in object storage. Object storage is, again, raw, unformatted, really cost effective. So that would be a great place to put these disk images so we can pull them down and deploy our virtual machines much quicker. And we're pulling data from our own region in most cases. So object storage is great for a lot of these things your application will ask users to download from or ask users to upload to. Shared files. So we've all understand the concept of a file share, right? Normally in-house we'd have a server, maybe somewhere in the back room or in the server room, and that would control our file share. And all the files that we all worked on together in the office would be there. So with the cloud, now we can access it across different networks. It's much easier because all the data is in the cloud. We can still perform that security and access control that we always did before to make sure only people who can view these shared files actually have the access. and it's highly scalable data access. So if we use a service like Azure Files, we can highly scale data as we need it and grow our storage space for our shared files as the need increases and we start using much more storage space. In this video, we're going to discuss and investigate the concept of indexes in a relational database. So as you can see, I have my SQL database set up. It's called RDS Richard Spencer. It's all set up in Azure. So once I'm ready, I'm going to pull up SQL Server. And we'll log into the database and we'll take a look at some of the indexes. We'll create an index and we'll talk about the process and the different type of indexes there are. So once I bring into SQL Server, I give my server name, my login, and my password, and I connect to the database. So you'll see this database, RDS Richard Spencer, and under database you'll see tables, views, synonyms, right, all the things that make up our database. Let's expand tables and take a look. This database has 3 tables: ingredients, persons, and recipes. So if I click on the database and I come in and I say new query, let's take a look at creating some indexes. So an index is just an on-disk structure associated with a table or a view, and it's used to speed up the retrieval of rows from a table or a view. So sometimes if your database is sluggish, it can have something to do with the index not being optimized. So an index contains keys from one or more columns in a table or a view. These keys are then stored in a B tree, and that enables SQL Server to find the rows or the rows associated with that key very quickly and very efficiently. So you can have 3 types of indexes. You can have a clustered index. These clustered indexes sort and store the data rows in the table or view based on their key values. These are the columns included in the index definition. There can only be one clustered index per table because these data rows can be stored in only one order. We also have a non-clustered. So a non-clustered index have a structure separate from the data rows. A non-clustered index contains the non-clustered index key values, and each key value entry has a pointer to the data row that contains the key value. Both clustered and non-clustered indexes can be unique, so that means no 2 rows can have the same value for the index key. So let's take a look at some code. Here I have code to create a non-cluster index, and I have to create a non-clustered index with a unique constraint. So we have 2 different type of indexes. So I'm going to go ahead and say create index. I'm going to call it index 1 on DBO persons, and I'm putting in the column name of person ID. So I want to create an index, call it index 1. I want to create it on the persons database, and I want to create it on the person ID. So I highlight it and execute. Commands have created successfully, and now I have a non-clustered index on DBO persons using the person ID column. Here I can use a unique index, right? So it's still a non-clustered index, but it has a unique constraint. So I say create unique index. We can call this index 2 on DBO.persons. And then we have to specify our 3 columns. So I'm going to say on person ID descending, on last name ascending, and first name descending. So I can highlight the code, execute it, and I create that index. So basically now, and anyone pulls back any data on persons is going to use that index to pull it back using those 3 columns: person ID descending, last name ascending, and first name descending. So that would be a non-clustered index with a unique constraint. So now if we come over to the left under DBO persons, And if we come down, we'll see indexes. We can expand indexes. Now you'll see the indexes that we created. 2 that were created before and 2 that we just created. It tells you if it's non-unique, non-clustered, unique or non-clustered. You can click the index and it gives you a pop-up. It shows you your index key columns, any other included columns, some options, right? That we can allow row locks, page locks, right? And this is your index property. So I hope this video showed you how to not only understand why you would want to use an index, but how to create an index and then go in and look at your index properties to make sure everything is exactly how you want it, because indexes are important for the performance of your relational database. In this video, we're going to discuss and take a look at some views and how it relates to a relational database. So I'm in my RDS, Richard Spencer, Azure SQL database, and you'll see here I have a few tables, ingredients, persons, recipes. But if you also come down on the Object Explorer, you'll see a folder called Views. So what is a view? A view is a searchable object in a database, and it's defined by a query. So the view doesn't store data itself, and some people refer to views as, say, virtual tables, but you can query a view like you can query a table. A view can combine data from 2 or more tables using joins, and it also can just contain a subset of information. This makes them convenient to, say, hide complicated queries, hide certain columns, or abstract complicated queries. A view is created from a query using a createView command. So a lot of views are included when we actually spin up our database. So if we expand the views, and you'll see system views. So these are a lot of the views that were created when the database was created. So you can see there's quite a few of them, and they're all started with SYS, right? So if we can look down, we can see all the system views. These are mostly related to configuration and server properties. But if we wanted to create one ourselves, we can come on the table, do a new query. So I can come in, I can say create view, call it Canadian cities as, and I'm going to say select first name, last name from dbo.persons where city in Montreal, Calgary, Toronto. So if I execute it, and commands have completed successfully, so if I do a refresh, come back down under views, now you'll see dbo.Canadian cities. So this is our view. Basically, we're going to use this view now to pull back any of our users or our people that are in Montreal, Calgary, or Toronto. We can create views if we had a table based on books, and if we had a column called is popular, and if it was popular, it would be equal to 1. So I'm going to go ahead and create a view. So I'm going to say new query over here, and I'm going to paste in my code, and I'm going to say create view. I'm going to change it from Canadian cities to American cities. So as this view, I want you to select the first name and the last name from DBO persons, where city is New York, Chicago, Boston. I can run it, and my view has created successfully. So if I come back over to my database and do a refresh, now we should be able to see our 2 views, the American cities view and the Canadian cities view. So again, these views it makes it easier to complex joins and pull back more abstract data. So I hope this video showed you not only why we use views, but how you can go ahead and create some views to really optimize your database. Now let's take a look at some of the Azure relational database types. So Azure gives you many choices of fully managed relational databases. These are intelligent databases and extremely flexible. So they can be SQL, no SQL, in-memory databases, a lot of proprietary databases, a lot of open source engines, whatever you need to fit your modern application. All right, so it'll save you time and money because it's fully managed. It's intelligent enough to scale up and down as needed and flexible as well. So it gives you the opportunity to build your applications without having to worry about a lot of the underlying technology. You don't have to worry about scaling. You don't have to worry about managing security threats. It's all done for you. The Azure SQL database. So you can build modern cloud applications with a lot of these managed Azure SQL database offerings. One of these is the SQL database. It's an intelligent, scalable, relational database built for the cloud. You can choose a serverless compute where you don't have to worry about any of the servers. It enables for hyperscale storage options so you can automatically scale on demand. And it's AI powered and automated. So all your scaling is all done on demand and automatically, right? We can use the artificial intelligence to see how the database is being used, how much resources is being used, and then we can scale proportionally based upon that intelligence that we receive from the database management system. The Azure SQL Managed Instance. So you can migrate your current SQL workloads to Azure and still maintain a fully complete SQL Server compatibility. The Azure SQL Service Portfolio is an intelligent cloud database service that you can use to modernize existing apps. So if you already have a SQL instance on-premise, you want to modernize it, bring it to the cloud, this is the product for you. It's highly scalable and it uses Azure Arc, right? So you can run this service on-premise on any of your infrastructure that you're currently running. And you can take advantage of these cloud benefits like elastic scale, unified management, and a cloud billing model, right? So that is your option to integrate your current SQL to a more intelligent cloud-based SQL offering. SQL Server on VMs. You get the performance, security, and analytics that you're always used to using. You get flexibility and hybrid connectivity. So the fact that you're running it on virtual machines allows you to have full, complete control over these machines, right? You got 100% code compatibility, and you can just lift and shift your SQL Server workloads to the cloud and take advantage of these high performance, secure, flexible SQL Server on VMs. So you can access the latest SQL Server updates and releases, including even SQL Server 2019. PostgreSQL. PostgreSQL offers us single zone or zone redundant high availability. It allows AI-powered performance optimization and advanced security. So you can migrate your current SQL into a PostgreSQL and take advantage of all the Azure offerings that you can use, such as single zone or zone redundant high availability. So we can run our SQL servers over multiple zones, right? And then we could take advantage of that AI-powered optimization to scale in and out when we need it, and all the advanced security options that come with your Azure account, right? So this is a great option for you as well to begin your migration into data management in the cloud. Another option is MySQL. So you can deliver high availability and elastical scaling open source mobile and web apps using MySQL. Great for application development, not so much data management, but application development. It's easy to set up, it's easy to operate, it's easy to scale. You still get to take advantage of the advanced security and the high availability up to 99.99%. And you can choose a single zone or zone redundant high availability. So if you want an open source option, here is your option right now with MySQL. MariaDB. The Azure database for MariaDB is another relational database service that you can use on the open source MariaDB server engine. It's a fully managed database, great for mission critical workloads, gives you predictable performance and dynamic scalability. Right, so it's fully managed. Again, you don't worry about any of the underlying infrastructure. The high availability makes it great for mission critical workloads. And that predictable performance and dynamic scalability goes hand in hand, because when we start seeing performance go up and down, we can dynamically scale to match that performance. And you can also leverage the open source tools and platform of your choice, right, when you're developing applications with the Azure database for MariaDB. Let's discuss Platform as a Service. Platform as a Service gives us ability to have an environment for building, testing, and deploying any of our mobile applications or software applications without having to invest in the infrastructure behind it. So the goal is for developers to be able to spin up and create their applications and their infrastructure really quickly without having to manage that underlying infrastructure. So you can deploy a web application using PaaS, but you don't have to install the operating system. You don't have to do any system updates. It's all managed for you, right? So it's a complete development and deployment environment in the cloud, because as a developer, you're not worried about the infrastructure and the servers. This takes up your time. So by Azure offering you a platform as a service, it's here you go. Here's your platform. It's ready for you to build, test, and deploy on, and you only worry about your application and your code and leave the infrastructure to us. Platform as a Service offers many development tools, database management, SDKs, for example, monitoring tools. These are all built into your Platform as a Service. You get a choice of multiple operating systems. Maybe you want a Windows operating system. Maybe you need a Linux operating system. Maybe you're getting into machine learning and you want a machine learning fine-tuned operating system. These are there for you. You don't have to go and procure these things. Servers and storage. What would have taken you as a developer a lot of time to procure the servers, procure the storage, set it all up, configure it, right? When that's not even your main goal. Your main goal is to get that application out there. So Platform as a Service takes away that procuring and configuring and managing of servers and storage. You just work on your code software application. Networking is another thing you have to get into if you don't go Platform as a Service. If you manage all this yourself, now you're managing your network. Again, far outside the scope of what you're trying to accomplish. And the data center, the physical building itself, right? The air conditioning, the heating, the security, all this stuff. So this is things that you as a developer don't want to deal with. And when you use a Platform as a Service, you don't have to, because the service provider takes care of all this for you. Platform as a Service is typically used for a few scenarios, one of these being development framework. So you give your developers this cloud-based environment that they can build these web applications, these rich cloud applications, without having to worry about, again, any of the physical infrastructure. PaaS lets developers create applications using built-in software components. They have built-in scalability, built-in high availability, right? So it gives you a lot more resources at your fingertips. It also integrates great with analytics or business intelligence. A lot of these cloud providers have a lot of analytical services or business intelligence services. We can tie that into our application, and it's all in one spot. And we can send all of our data over to some OLAP analytics processing if we need to, right? And again, the beauty of this is that that's also managed by a platform as a service. And there's some other additional services they may use platform as a service for. It's great for making it easy to launch these web applications. It's great if we have our application, it's in-house, but maybe we want to migrate it to the cloud and take away some of that, again, some of that overhead like physical infrastructure, heating and cooling. Maybe we use platform as a service to push out our applications to edge locations so we can speed up our application's performance in different parts of the world. Right? So opportunities here are basically endless. Some of the platform as a service advantages. You cut coding time, right? Sometimes you have pre-coded applications ready for you or starter applications that you can use. You have directory services that can easily integrate. So a lot of things that you would have to code to integrate with, you don't need to do that anymore because it's already automatically integrated. Development capabilities, right? We can add more developing without adding, say, more staff. We now have capabilities to do things that maybe before we would have had to hire in-house to perform for us, right? So we're, again, increasing our efficiency. We've got sophisticated tools, right? Maybe you want to use a pay-as-you-go model. Organizations, developers can use these sophisticated development tools and business intelligence tools that they normally probably could not afford to do. And development teams. You have locations all over the world where developers are working. We don't need VPNs anymore. We just all connect to the same cloud on our web browser, right? So that makes it way easier for our development teams to work together no matter where they're situated in the world. And the application lifecycle. Platform as a service provides all the capabilities that we need to support the full, complete application lifecycle. So building, testing, deploying, managing, updating, that's all included with your platform as a service. So as you can see, there's so many great opportunities here that it almost makes me wonder a lot of the times why people still decide to spin up their own data centers and do a lot of this in-house. What are some of the platform as a service costs and ownership? Upfront costs? Nothing. You pay for what you use. Gone are the days of buying servers. Gone are the days of buying networking equipment and firewalls. Right? That's no more. You pay for the resources you use. So if it sits idle, you're not using it, you can shut it down and not pay for it. You can't do that with physical servers. You bought the server. It's yours. User ownership. You, as an owner, you're only responsible for the development of your applications. You're not responsible for managing the server or patching the server, right? So that allows the user to focus on the application they want to run and only that application. And is there any cost to cloud provider ownership? Right? The cloud provider is responsible for operating the system management, the network, all the service configuration. So they're typically responsible for everything apart from the application that you want to run. So they provide that completely managed platform. And again, it's all pay as you use, right? Pay as you go. If you don't need a specific server, shut it down and not pay for it. It's a much easier and cost-effective way for a developer to get their applications up and out and running on the web as quick and efficiently as possible. Now let's discuss infrastructure as a service. Infrastructure as a service gives you the opportunity to be able to have a full running data center, but not actually have to manage that fully running data center, right? So previously you would have to go out, you'd have to purchase your servers, you would have to install all the operating systems, all the software, you'd need to configure it all, and you'd have to go on and manage it from day-to-day operations until end of life. Infrastructure as a service, you don't have to worry about that anymore. You pay for what you need. You spin up your infrastructure, your servers, your databases, whatever the case may be, on your cloud provider, and you connect over a web browser. So you instantly provision your infrastructure and you manage it all over a web browser. So we don't have to worry about heating. We don't have to worry about cooling, management, physical security of our data center, right? That's gone. Now we just access our infrastructure, whether it's a fully functional network or a fleet of servers. We access it all over the web browser because it's all contained in our cloud provider's data center. Infrastructure as a service is great for migrating workloads, right? So these facilities are managed in a similar way as on-premise infrastructure, and it can provide an easy migration path for moving your existing workloads into the cloud. Great for deployment testing, right? If you got deployment teams, they can quickly set up and tear down test and deployment environments. If you use, say, infrastructure as a code, you can spin up a fully functioning environment via script, do your deployment testing, then tear down your full environment in a matter of minutes. Try doing that in a physical environment. And storage backup and recovery. Now you don't have to worry about all the capital expenditures for backup equipment. You don't have to worry about managing the backups. A few clicks and you're configuring your backup, and it's all taken care of at the cloud provider level. So it makes that much more simple as well. So what makes up infrastructure as a service? Servers and storage. That can be object storage. That can be file storage, right? That can be storage that go on your servers, so instance storage. We've also got networking. So whether we want to set up a virtual network in the cloud, complete with firewalls, internet gateways, NAT servers, access control lists, right? That's all there as well. And we can essentially replicate a full-blown data center in the cloud. Because before we'd have to acquire a building, set up the physical hardware for networking, set up the physical storages, configure. We're talking months, right? With the proper infrastructure as code and infrastructure as a service, we can spin up a fully functioning data center in an hour, right? So it's so much faster and much simpler, and you're paying for what you need. Infrastructure as a service user management. Infrastructure as a service requires the most user management of all cloud services. Software as a service, you may have to manage the data. Platform as a service, you may have to manage specific coding platforms. But with infrastructure as a service, you have to manage your applications. You have to manage the data in those applications. Any runtime libraries are your responsibility. Any middleware you're going to use is also your responsibility, as well as operating systems. So if you want to install any operating systems, your user is going to be responsible for that as well. You're given the server, you do with it as you want. It's not a managed service. So when would we use infrastructure as a service? First of all, high performance computing, right? We can run supercomputers or grids of computers or clusters of computers that can solve some complex problems. A lot of these cases can be weather predictions, stock market predictions, these type of things. High performance computing. Web hosting, right? We don't want to set up an in-house hosting for one simple website, so we're going to use a infrastructure as a service and put our application up on the cloud. And we can also use it for big data and analytics. where we set up the servers and the infrastructure we need to ingest the big data and run any analytics and historical processing on it. Something that would take a lot of horsepower in-house. And finally, web apps. So maybe we're running apps in-house, our infrastructure is starting to get old, we don't want to have to upgrade it. Now would be a great time to take advantage of infrastructure as a service and push our web apps out into the cloud. Some advantages of infrastructure as a service. Availability. So it's not your responsibility anymore to make sure the power is still on to the building, right? Or to make sure the cooling is fine. So it's always going to be available. You got service level agreements to make sure that your infrastructure is available. Disaster recovery, right? You can respond more quickly to disaster recovery, whether you're using multi-regions or whether you have backup scripts to recreate your environment, right, in another area. Reduce costs, so it eliminates that capital expenses because we're not purchasing equipment anymore, and it reduces the ongoing cost, right? So it sidesteps the upfront expense, and your ongoing cost of management is also reduced. It's stable, right? We know that companies like Microsoft who run these big data centers, their infrastructure is stable. So if we're using their infrastructure, we can definitely rely on the fact that it's not going to crash on us and it is in good shape. And finally, security, right? So we've got many security opportunities given to us in the cloud, whether it's user management, whether it's firewalls, ACLs. We've got a lot of security products that we can incorporate to take advantage and really secure our infrastructure. So why would we use infrastructure as a service, or where can we use infrastructure as a service more? One thing could be remote work. We can deploy virtual desktops, have people work anywhere. Great for cloud backup, right? If we want somewhere to back up our data, rather than having someone take home a removable drive every day, let's just back it up to the cloud, right? The cloud's not going to lose the data, but someone bringing home a removable disk every day, the opportunity is there to lose that data. Built-in security controls, hybrid environments, right? So maybe we have an on-premise, we hook it up to infrastructure as a service in the cloud, and we're running a hybrid environment. Migration, so we may start to migrate some of our services to the cloud, so we can spin up some infrastructure as a service products like maybe a server, storage gateway, and start migrating over to infrastructure as a service. Cloud connected devices and cloud connected applications, and cost optimization. So again, we're not paying for stuff sitting idle anymore. We're only paying for what we're using. So infrastructure as a service cost and ownership. There is no upfront cost. So compared to traditionally where you have to go out, buy the building, buy the servers, buy the storage, that's gone anymore. It's no upfront cost. You only pay for what you use. User ownership. So you're responsible for installation, configuration, and management of your own software, your own operating systems, middleware, and application. You don't worry about the hardware type. And provider ownership. So the cloud provider is responsible to make sure that that underlying infrastructure, the virtual machines, the storage, the networking, that's all available for the user. So it's a separation of responsibilities. Now let's discuss software as a service, commonly known as SaaS or SaaS. Software as a service is a centrally hosted and managed software for the customer, and it's located at the cloud service provider. It's cloud-based apps. So a lot of times like Microsoft 365, accounting software, such as Simply Accounting, is now all web-based, right? So most of the stuff that we used to download and install on everyone's computer is now just accessible via the web using a web browser. You pay a subscription, usually monthly or annually, right? But things again like Microsoft 365, Skype, Salesforce, Simply Accounting, Sage, all these are now software as a service. Gone are the days where you get the CD and you install it on everyone's computer, right? And make sure they all can connect to a file server and share the data. That's gone, right? The software is now in the cloud service provider's infrastructure. They provide it to you over a web application or a web browser, and you just pay a monthly or annual subscription. Software as a service is great for using hosted applications. We don't have to worry about developing the applications. We don't have to worry about the operating systems. We don't have to worry about servers, storage, right? We don't have to install it and make sure that we have firewalls opened up so we can all save to our file server, right, in the server room. We don't have to worry about that networking piece or the infrastructure piece. We don't have to worry about a data center, right? So these things are gone now. We can access our software application right from the web. So when a new user comes in, there's no more installing it on their machine, testing. It's just, here's the link to your software, and you can access it via your web browser. Software as a service is the least amount of management. The cloud provider is responsible for all these things. So all you have to do is use the software. So what are some software as a service common uses? Email. If you've ever used Gmail, Outlook, Hotmail, Yahoo Mail, right, you've already used some form of software as a service. You're not installing a email management system onto your computer and setting up your POP servers and these type of things. You just go right to the web and type in www.hotmail.com, whatever the case may be, and you're right into your email system. Customer Relation Management, CRM, or Microsoft CRM, it's all now online. It's all web-based. Your company will get its own domain, and we can store all of our customer relationship management and all the information regarding our customers and leads and whatnot right through the web browser. Great for collaboration and calendaring. Office 365, right? We can look at everyone's calendars. We can collaborate. Maybe we're using Microsoft Teams, right? These are all software as a service capability. And enterprise resource planning, or ERP, right? So we can take these big behemoth ERP systems and we can use it in the cloud. So whether it's SAP or PeopleSoft, right? These can be software as a service now. We don't have to actually go ahead and install these on site. That takes a considerable amount of design, whether it's networking, server, storage, whatever the case may be. We don't want that. We just want to use our ERP system, right? So we can take advantage of that as a software as a service as well. Some of the advantages of a software as a service: sophisticated applications, things like CRM, right? Microsoft Customer Relationship Management Tool. It's sophisticated. There's a lot going on behind the scenes, lead generation. We've got ties between customers. We're storing all of our interactions, right? We don't have to worry about this install and making sure we've got the correct database sizes. That's no more. We don't have to worry about all the overhead of these sophisticated applications. We're using cloud-based technology. So we can take advantage of cloud-based backups. We can take advantage of cloud-based monitoring. And workforce mobilization. Never before have we seen a workforce mobilized to their homes, right? Or maybe you want to have a workforce spread all over the world. Having a cloud software as a service provider will make that so much easier. We can all use the same software no matter where we are. And you only pay for what you use. So if you had 5 users, you'll probably pay a license for 5 users, 10 users, and so on, right? So we're not paying an exorbitant amount of money for a software package that only 3 or 4 people are going to use. Its pricing model is much better as well. Software as a service cost and ownership. Right? Where does that line draw between ownership and what is the cost? Well, there is no upfront cost. You're going to pay a subscription fee for what you use, but you're not buying this software outright. User ownership. You'll own the data that is in the application itself. You'll have a license fee, but you don't own the servers that it runs on. You don't need to manage those servers, these things. So it's much better from a user ownership perspective. You own your data, but you don't have to go out and buy, again, that behemoth software package. And provider ownership. So what does the provider own? So again, the provider owns the servers. The provider owns the networking equipment, the physical location, right? You own your data. And it's a much better relationship because, again, we know who's responsible for what. The cloud provider is responsible for the infrastructure and all the things that it does great. And you as a user, you're responsible for the application data and using that application in a way that benefits your business. Now let's discuss online transaction processing. The management of transactional data using computer systems is often referred to as OLTP, or online transaction processing. It takes care of transactional data. That data must be atomic, so it must be of the smallest size possible, right? The lowest level data unit, and it must be consistent. Transactional data is essentially just information that tracks the information and interactions related to your organization's activity. They could be business transactions, they could be payments received, payments sent, so on. So it'll track all of these interactions, whether they're business transactions, payments, products, inventory, right? Any orders you receive from customers, services. So you may have service that's a data workload service or data analytics services. It tracks all of these interactions as well. So transactional events that usually represent transactions themselves. They usually contain a time, date stamp, some numerical value, and reference to other data. So if there was a purchase, there would probably be a time, there would be numerical data around that purchase, and there would be a reference to more in-depth data about that actual transaction. OLTP, when to use it, right? So if you need to efficiently process and store transactions, as well as query transactional data, that's great uses for online transaction processing. Data normalization, so breaking up data into smaller chunks that are less redundant, is also another option to use OLTP for. And to process a large number of transactions independently. That'll avoid the extra processing needed to maintain the data integrity in the presence of redundant data. Some of the challenges related to OLTP are aggregate calculations. So a lot of these OLTP systems aren't always the best for handling data from aggregate areas, right? So we're getting a large amount of data from a lot of different places, and we need to aggregate them. So analytics against this data that rely on aggregate calculations over the millions of individual transactions can be very resource intensive for these OLTP systems. When we're doing analytics and reporting on data that's highly normalized, these queries tend to be complex because these queries need to denormalize the data by using joins. And sometimes naming conventions for database objects in these online transaction processing systems tend to be terse and succinct. So this increased normalization makes OLTP systems difficult for business users to query. And finally, an indefinite history of transactions. So storing the history of transactions indefinitely and or storing too much data in one table can lead to a slow performance. So you have to make sure these OLTP systems will work for what you want it to work for. OLTP in Azure. Applications like websites hosted in App Service web apps, any REST APIs you create, any mobile or desktop applications will communicate with the OLTP system, typically by use of another API, right? So in practice, most workloads aren't just purely OLTP. There also tends to be an analytical component to it as well. So that means there's an increasing demand for real-time reporting, business intelligence, right? This is referred to as hybrid transactional and analytical processing. So in Azure, most of the data stores that you use will meet the core requirements for OLTP, such as Azure SQL Database, SQL Server in virtual machines, MySQL, and PostgreSQL. So deciding on an online transaction processing system. Do you want a managed service? Do you want to have to worry about the underlying infrastructure, or do you want that taken care of for you? The scaling, high availability. Do you want that managed and you only worry about your actual transactions? Do you have specific dependencies? Do you need SQL Server? Do you need MySQL or Postgres compatibility? Throughput requirements. Are your write throughputs going to be high? Right? If so, you have to choose an option probably with something like in-memory tables. Low latency. So is your solution multi-tenant? If so, you might have to use support capacity pools, where database instances draw from an elastic pool of resources. You want high availability, right? You want it to be up all the time, multiple region support, security. So we're dealing with a lot of high financial transactions. That needs to be secure. You're dealing with credit card numbers. You're dealing with customer orders, customer information. So security is a must as well. So you have to make sure that the security offerings for your OLTP system are going to fit your need. So what do we need out of an OLTP system? We need the general capabilities of any OLTP system. We need to track our transactions and store our transactions in a secure manner. We need scalability. We need to be able to scale up when demand needs it and scale down when we don't. We need analytics. We need to analyze our transactions, see how we can get better, see where we need to put extra resources, right? We are nothing without the data and the business intelligence around our data. We need high availability. We need it running at all times. This is not something that can be up and down. And security. So we need that security to protect our data and our transactions. Now let's discuss online analytical processing, or OLAP. OLAP is a technology that organizes large business databases and supports complex analysis. So it's really the driving force behind business intelligence. We're taking large amounts of data from many different areas, and we're doing some complex analysis on that data for business intelligence reasons, such as maybe you want to increase marketing in a specific area, any reason to look at your data and make business decisions based on that data. It allows for highly performant data extraction. So we're pooling that data out with high performance, very fast, because again, we want real-time information, and it's optimized for heavy reads and low writes. So we're analyzing, we're taking the data and we're reading it. We're not writing to it as much, but we're reading to it. So we're optimized for heavy read as well. OLAP semantic modeling. This type of modeling provides a level of abstraction over the database schema. So the users don't need to know the underlying data structures. So it's easier for end users to pull back data, do joins, any aggregates, and so on. This type of modeling is heavily used for read-heavy scenarios, just like we have in OLAP, right? We're doing mostly analytics and business intelligence. So This is good for that type of modeling. Aggregation behaviors. We're setting aggregation behaviors so that the reporting tool display them properly. Again, we're pulling data from many different sources, so we need to aggregate data. Business logic and calculations are defined. Not every business do things the exact same way, so there's going to be different business logic amongst our analysis, so we can define those. Time-oriented calculations are always included. Again, we need time-oriented data if we're going to do any amount of analysis on our business transactions or whatever we're going to actually run these high-level business intelligence applications on. And integrated data. Again, data is integrated from multiple sources. It's not always just one source. So we need to take that into account when we do our modeling for our OLAP system. So with regards to online analysis processing, there's two types of semantic models. We have tabular models. These, if you think back to relational databases, this uses relational modeling, such as tables and columns, and internally that metadata is inherited by OLAP modeling constructs like cubes, dimensions, and measures. We also have multidimensional. So that uses traditional OLAP modeling that we've always heard before, like cubes, dimensions, and measures. So multidimensional is more traditional. Tabular kind of brings in some of the relational data advantages along with some of the multidimensional advantages as well. So it's more of a newer offering. So when do we use OLAP? When do we take into consideration that we may need some type of system that's going to allow for our analytics? Consider OLAP if you have complex analytics that you need to do. This is exactly what it's defined for. This is exactly why people use it. Report generation. You might want to generate reports from all of your data. And again, your data is aggregated. It's coming from multiple different streams. So you want one piece of software that can analyze all those different data and give you the report you need. You don't want all the excess data, right? If you're an executive and you're making business decisions, you just want the data you need. You don't want to have to kind of scroll through useless data. So report generation here is important because it takes the data from all these different areas, aggregates it, and gives it to decision makers for them to aid in making decisions that's best for the company. And if you want consistent results. So if you want to have a number of aggregations, but all your users will pull the same consistent results, no one's going to pull different values, then this is what you want to implement here as well. Some of the challenges with OLAP, right? What are some of the issues that you may see? First and foremost, data store refreshes. Right? Data in these OLTP systems are constantly updated through various middleware transactions. OLAP data stores are refreshed at much slower intervals because remember it's read heavy, write low. So that means these systems are better suited for strategic business decisions rather than immediate responses to changes, right? Because where we're writing less and we're reading more, the data store is a little slower to refresh. Another challenge is mapping entity relationship or object-oriented models. So normal relational tables found in OLAP systems, OLAP data models tend to be more multidimensional. This makes it hard, or sometimes even nearly impossible, to directly map to entity relationship or object-oriented models, where each attribute is mapped to one column. Instead, these OLAP systems typically use a star or snowflake schema in place of traditional normalization. So what do Azure offer in terms of online analytical processing? What type of OLAP systems can we find on Azure? Any data held in OLTP systems in Azure, like SQL database, for example, is copied into the OLAP system, such as Azure Analysis Services. From there, we can do data exploration. We can use graphs and visualization tools to really make these business intelligence decisions. It also offers SQL Server integration services and SQL Server analysis services. So we can integrate it with your SQL Server and we can do analysis on it, right? So you can either install SSAS on any local servers or you can host it within a virtual machine. But Azure offers you a lot of options when it comes to online analytical processing. So when you're deciding on OLAP, what do you want to take into consideration? You want to take in the fact that you want to manage service. You don't have to worry about the back end, the infrastructure. You also need secure authentication. So do you want to use the Azure Active Directory? You can integrate it with. You want real-time analytics. So you're going to have to narrow some of your options down if you want real-time analytics, as not all these OLAP systems do support real-time analytics. So pre-aggregated data means that that data is already aggregated for you because, again, it's coming from multiple different sources. It's coming in multiple different shapes. So we want to have that data pre-aggregated. We want to be able to have it integrated. So we want integrated data. Do we want to integrate data with different services within Azure? Maybe we want to store some of this data. We can get some object storage or whatnot. So these are the factors you have to consider when you're deciding on an OLAP system that you're going to implement for your organization or your application, whatever the case may be. OLAP capabilities. So it has general capabilities. It's managed. It has multidimensional cubes. It supports tabular semantic models. It's easy to integrate with multiple data sources. Supports real-time analytics. It's also scalable, so we can scale up and down as we need. It has scaling capabilities for high availability. It supports query scale out, and it has dynamic scalability to scale up. So in this course, we've examined relational data workloads, indexes, views, and delivery models. We did this by exploring characteristics of relational data workloads, indexes, and views, Azure relational data delivery models, Azure platform as a service, infrastructure as a service, and software as a service, and online transaction and analytical processing. In our next course, we'll move on to explore basic management tasks for relational data.